In this video series that we are doing right now, we have covered three things. One, how to start with vibe coding, the basics of it. Second, how to build a basic chatbot, which fetches information from Wikipedia. And third, how to make the best use of the free credits that you get from these vibe coding apps like Lovable and Cursor. And I told you that in the end, we'll build our own chatbot, which works on our own data. It interacts with you, it fetches information based on the product, services, or anything else that you want to store in the database. But before we do that, I thought I want to cover one topic which is a little tricky, a little complicated if you are not very technical, which is databases. And in this context, I'm talking about vector databases, which are very specific to AI. So today I thought that I'll explain a little bit on what vector databases are, how they are different from relational databases, the traditional databases that we have been using or we know about, and what is RAG. Because the combination of RAG and vector databases is something that we will use in all of our chatbots and other similar automations. I worked on a quick presentation, tried to make it as simple as possible so that all the basics are clear to you. Just the basics. You don't need to learn how to build these things, but need to understand what goes behind the scenes, what goes under the hood. So let's jump right in. Even if you're not aware of relational databases, the traditional databases, I'm sure you must have used those, especially if you are in marketing. Google Sheets, Microsoft Excel, these are very good examples of traditional relational databases. You must have seen these rows and columns where you have, say, for example, item IDs, which could be a unique column as well. Then you have items in their category. So for example, orange is a fruit, color is orange, total stock price in USD. And these relational databases, they are good and almost perfect for exact lookup. So if I'm looking for something like cat food, like the exact match, and how much do I have in stock, how much cat food do I have in stock, then I can use a relational database, because then I can search with item name cat food and the total stock is 120. And if I'm looking for the price of, say, salad, then I can easily fetch it from that exact search, which is I'm looking for salad, what's the price? It's $5. So you see, because I am looking for exact things, be it within this column, within this column, or any other column, I need to be exact about what exactly I'm looking at. Yes, there are some ways to do some regular expressions and stuff, but still the context, you cannot do a contextual search that I am looking for food, which is, say, refreshing in summer. I don't think it can find it for you, that if you're looking for something refreshing in summer, because you have name, category, color, stock, price, nothing about refreshing. The context is not there. So that is the biggest problem with relational databases. Now let's look at the vector databases. Vector databases, they work on semantics, they work on the context. So instead of storing exact information, they create vector, which are dimensions, you can say. So it point to a certain direction, that look there, look there. So maybe one dimension is all about color, another dimension is all about if it's food, third dimension is all about is it an animal or is it a fruit. So these are all dimensions that it works on, and it groups things together based on the context or how closely related everything is. So for example, the color here is orange and its dimension, the address is 3.5, right? So anything which is close to color orange will be close to this particular number. For example, 2.2. This tabby, this orange cat is not perfectly orange, but it's close to orange. So it will be somewhere nearby 3.5. But this bowl of salad, it has some orange, but not a lot. So it's a little far away. And similarly, if we talk about food, so for example, orange, is it a food? 4.9. Then the closest thing is this salad. This is 7.2, because this is closest to the food, and 4.9 is a little far behind because it's a part of the food, but not the whole food itself. Similarly, this human is eating something. So yes, there is food available there as well. Is it an animal? 9.1 for cat, because this is the closest thing that we have to an animal. When it comes to orange, it's not close to the animal. And similarly, when it comes to, say, is it a fruit, then yes, the highest one is your orange, and the closest to it will be the food items, because it might have some fruits in it. And because of this, you have this array of numbers. This is the dimensions it's pointing out to. And how it works is, because of this, it's not 2D. You don't have x-axis and y-axis. You have a very different thing, which is multi-dimensional. So if we just talk about the text, because for example, if we are uploading a lot of data around what exactly my company does, so I'll just save a lot of data in my database, which is all about my company, but probably in text format. So in this example, the same thing, but instead of a photo of orange or a mandarin, I'm just putting a text here. My friend has an orange cat and I love him. So it works in the similar way. It will collect all the similar contextually relevant text, chunk of text, in close to the dimension which is more relevant to it. Similarly, how it's stored, just like I said, it's not in X and Y format like the way we used to do with, say, our traditional databases, relational databases, Google Sheet, Excel, for example. Compared to this traditional or the relational database, a vector database is multi-dimensional. It does not have X or Y axis. The array that I was talking about, the multiple dimensions, it could be in hundreds. So instead of just 4, there could be hundreds of attributes which are putting them into different dimensions. So it's just an example to give you that how exactly it works, or how can it work. So now I hope it's clear what vector databases are and how they are different from your traditional relational databases. This brings us to something that we are going to use in our automations, which is called RAG. You must have heard about it, read about it. RAG, maybe you also know the full form of RAG, which is Retrieval Augmented Generation. So what exactly is RAG? For a non-technical person, it is just a process most AI apps or automations they use to talk to the vector database. So if you just look at the full form of RAG, which is Retrieval Augmented Generation, basically what happens is, if you are using RAG, the LLM will not respond to you unless it looks into the vector database first. It will go refer to the data stored in the vector database, only then it will respond to you. So the chances of LLM giving you some random information or hallucinating are very less, because now it's looking at a specific information. It's going to retrieve it first before responding to you. So how it works is that as soon as you activate RAG, the retriever, it goes into the vector database. It retrieves all the information which is close to what you are asking for, and then gives it to the LLM, say ChatGPT or OpenAI or Gemini, whatever you're using. So it gives all this closely related, interlinked, contextually relevant information to the LLM. It will just parse everything and give it to you in very simple terms. So whenever you have a conversation with any chat interface, say OpenAI's ChatGPT or Gemini, it's not like they have their own brain. They are going through a database. They are going through a database stored in OpenAI servers, and it will go through everything that's stored there. And because the response is instant, the speed cannot be achieved by using your traditional relational databases. That's where vector databases, they came into play, and RAG is something which enabled the speed and accuracy. But the question is, do you really need RAG? You must work on a lot of automation. Sometimes you would want to read through spreadsheets or Google Sheets, right, where some reports or some stock inventory is stored, and you just wanted to fetch some information. Do you need RAG for that? Not really. While technically it can, because RAG can also talk to your relational databases. But certain data, certain queries that we come across or that we ask our databases may not work with RAG if it's just using a traditional relational database. So for example, I have this relational database on the left, which is the items, the stock inventory, and also the price of each of the items that I have in stock. It's stored in a relational database. Now, if my query is, what is the current stock of oranges? As simple as that. It can easily go into the item name and find the total stock which is available in your inventory, and it'll tell you there are 250 oranges. But what happens if you ask it something like, show me things which are refreshing in summer? There is nothing refreshing here in this relational database. I can't see anything here which says refreshing. So that's where your AI or the automation that you're working on, or the chatbot that you're working on, it will not give you the information that you're looking at. That's where the vector databases, they come into play, because now it will look at the context as well. It will go look into the vector database and return oranges and also a salad, because these could be refreshing. The context is there, so it doesn't need to be the exact information. Till the time there is some context, it can recommend. So that's how AI is much better at recommending things based on what you are thinking or talking about. So in a nutshell, relational database is good for exact searches when you are looking at things like, say, item name or the stock or the price. However, when it comes to vector databases, they store meaning. They can handle semantic searches. It can provide you context aware answers. I just do on top of it in any case. So yeah, it can provide context aware answers, which is not exactly what is stored in the database, but it's closely related to what you are looking at. So the reason I'm doing this video is to tell you about why certain things are really important. If you don't want to use vector database or RAG in your automations, you can do that. You can just connect your automation with a Google Sheet or an Airtable database or anything like that. But the responses will not be accurate. A lot of times it will just hallucinate till as soon as you ask something which is not stored in the database exactly as what you are asking for. So relational database for exact matches and vector databases for semantic similarities. And once you are clear about this small concept, we can now jump into building our own vector database based on the information that we want to store, so that we can build a chatbot which can look up this information and talk to your potential customers. So a use case for that, I told you earlier, for example, if you are an e-commerce company and if you have a lot of things that you sell. So for example, if you are into t-shirts and you have different types of t-shirt, different colors, patterns for different genders, and then people will also ask about the quality, the material, and shipping times and things like that. We are going to store all that information in a vector database, then link it to our chatbot automation so that it can start talking to your customers and give them all the relevant information. So in our next video, we are going to use a vector database which is within Supabase, upload all the information there, then connect it to our automation, and we will have our own chatbot. I hope you liked this video. I had to do these filler videos while we are working on the automation so that the concepts are clear to you. So if you like it, please subscribe, give me a like. It helps. Thanks a lot. Cheers.